Alright guys, welcome to today's class. So what we're doing is actually JAMP. So we are doing the question on JAMP, GTMA JAMP 2014, and the topic we are doing is, and the subject we are doing is chemistry. So don't forget the past question 2014, chemistry. So let's start with the first question. They said which paper type. So those times they normally use paper, and the paper type there is paper type E. So that will be your answer. So that's how they do it those times. But it's not like that again. So is there a mixture of different? I think I should try to zoom it. Okay, I think by now you should be able to see it very well. So they said a mixture of two different. A mixture is different from a compound because of what? So what's the difference between a mixture and a compound? So that's what they're asking. I told you when I was teaching you about matter, I told you that mixture is actually an impure substance, right? So I told you that mixture is an impure substance, and mixture can be separated by separation techniques, right? So mixture can be homogeneous, it can also be heterogeneous, so it depends. So let's look at the differences. So the properties of a compound are those of its individual constituents, while those of a mixture differ from its constituents. That's not right, because the properties of a compound is independent of maybe the properties of the constituent elements. So it's different. So they are different things entirely. But this one is actually for mixture. What they said here is supposed to be for mixture. So why they say those of the mixture differ from its constituents. So that of mixture is not like that. So a mixture is always homogeneous. That's not really right. Now, so why a compound is not? Option C, the constituents of a compound are chemically bound together. Yes, that is correct, right? So they are chemically bound together. Chemically bound. But that those of mixture, they are not what? Chemically bound. And option D says a mixture can be represented by a chemical formula. That's why I told you that here, because here is a mixture. Have you ever seen them using a chemical formula for here? No. Although when I was teaching you descriptive chemistry, I told you that we normally represent air with oxygen. But on the normal notes, I told you guys when I was teaching you about air that we have like 4 components of the air. We have the nitrogen 78%, oxygen 21%, and carbon dioxide 0.03%, real gases and noble gases that is 0.97%. So I've taught you that already. So that one means it's telling us that what what can I say? It's telling us that oxygen is just used to represent air, but it's not really air. They are not synonymous. Air is different from oxygen. So what I'm just saying in essence is that mixture cannot be represented with a chemical formula, but compound can be represented by what? Chemical formula. That's why option D is not right. But the answer is what? Option C. Why? Because the constituents of a compound, they are chemically bound together. Let me go to number 3. They say what is the percentage of sulfur? Please, I did not teach you this under stoichiometry. So stoichiometry, please, they may ask you anything. If they ask you, so this thing I forgot to teach you under stoichiometry. So I don't think I talk much about stoichiometry. So I will be teaching you here now. They say what's the percentage of sulfur? So this is how to find percentage. If they ask you to find, if this is CO2, this is the compound CO2, and they ask you to find the percentage of carbon in CO2, all you just have to do is you find the molar mass of this compound. What's the molar mass of carbon? That is 12. What's the molar mass of oxygen? That is 16, right? And they ask you to find the percentage mass of carbon. So all you just have to do is you say what? You find the total molar mass of CO2 first. So that would be 12 plus, that is 16 times 2 like that. So 16 times 2. So then we have 44 like that. That would be your molar mass for the whole CO2, right? Now, for you now to find the percentage of carbon, it will now be carbon, the mass of carbon over that of the total mass. Then you multiply by 100%. So that's what you just do. So what's the mass of carbon? 12. The total mass of carbon falls at 44. Then you do it times 100. So that's how to do it. So the same thing with this one too. You already know they did not give us the molar mass. It is the molar mass of sulfur is 32. The molar mass of oxygen is 16, right? So they now say we should find the total molar mass of sulfur oxide. So what is sulfur oxide? Is it SO3 or SO2? So this is another thing. Is this SO2 or SO3? The answer is SO2. So sulfur oxide is what? SO2. So you now find the molar mass of sulfur oxide. That would be 32 plus, 16 times 2 like that. Oxygen, that is subscript. So you have 2. So you now have 32 plus 32. 16 times 2. So we have 64 like that. Now they ask us to find the molar mass of sulfur. So that will be sulfur, molar mass of sulfur over mass of, then you multiply it by 100%. So you have 32 over 64 times 100%. So at the end of the day, you are going to have what, 50%. So I did not teach you this aspect, so I apologize for that. So I think by now you know how to find percentage by mass now. So just try to solve more past question on it. So a gas X diffuses twice as fast. So this one is actually on Graham's law of diffusion, which says that the rate of diffusion is inversely proportional to the square root of the mass, the molar mass, or the rate of diffusion is inversely proportional to the square root of vapor density. So I've taught you that already. So look at this. They said the gas X diffuses as fast as gas Y. Okay, they said diffuses twice. Please make sure you note their terms. A gas X diffuses twice as fast as gas Y. They now said if the relative molecular mass of X is 32, calculate the relative molecular mass of Y. Now this is it. The rate of diffusion of gas X, according to the statement they say, is that it's twice as fast as. So it means that will be 2 times the rate of diffusion of Y, right? So and according to this formula, rate of diffusion will be R1 over R2 is equals to square root of M2 over M1. So that is telling us that Rx, if you have Rx over Ry, is going to be square root of My over Mx. Do you get? So let's do that now. So the next thing we want to do here is now they now said the rate of that. So now in place of Rx, you now put 2Ry there. So it now be 2Ry over Ry is equals to, now they now said what is the mass of Y? They're asking us to find that, right? They said Mx, what is the molar mass of X? So that is 32. So we now have Ry cancel Ry. Then we say 2 is equals to square root of My over 32. So let's find the square root of both sides. So we now have 4 is equals to My over 32. So let's cross multiply. So our My now will be equals to 32 times 4. So what do you have now? 128. So that will be your mass for. So can you see now that this thing is not hard? Just just know how it works, then you do your work. I think that's our number 3. Okay, number 4. That's number 4. So let's go to number 5 like this. So this one is actually on Boyle's law, and I've taught you that also. You can see that almost everything I've taught you everything. So 200 cm cube of a gas. So stoichiometry like that, I think I've taught you empirical and molecular formula already. So I sent a particular video on Telegram. So for that, so look at this now. They said the 200 cm cube of a gas, that is the volume. 200 cm cube at temperature. So that will be 25 degrees Celsius. Exact a pressure of, so that will be your pressure, 700 millimeter mercury. They now said we should find the pressure, calculate this pressure. So it means that will be our second pressure. So if the volume is what, 350 cm cube at which temperature, 75 degrees Celsius. So let's add 273 like that. So what do we have now? So that would be 298 Kelvin. So here to add 273. So what are you going to get? So let's try to use, let me bring out my calculator, and that will be 75 plus 350. Sorry, 75 plus 273. So we have 348. So though I'm still going to need that calculator again. So now we won't forget the formula for jet. So this formula is actually, we are going to use general gas law. That will be P1 is equals to P2 V2 over T2. So let me just use calculator. So what's my P1? That will be 700 millimeter mercury. What's my V1? 200. What's my T1? That's 298 times. What's my P2? That's what I'm looking for. Sorry, this is equals to, what's my V2? Where is my V2? So okay, my V2 is this, sorry, 315. Then our T2 is 348. So just calculate everything like that. So let's cross multiply. So we now have 700 times 200 times 348. So at the end of the day, just divide it by 298 times. I've jumped on some step. I've jumped some step, so I don't, because of our time, I'll not be doing it one by one. So we have 700 times 200 times 348 was okay. 298 times 350. So we have 467.11. So 467.11. So that's our answer. 467.11 millimeter mercury. So that's our answer. So you can see this thing is not hard. That's option C. So let's go to the next question. So the next question is saying, so look at this too. So look at this now. They said an element X. For those of you that joined the tutorial very late, this will help you to quickly revise. So look at this now. They said which of the following. So look at this element now. Now, whenever you have questions like this, I think I taught you a logic for doing this. So whenever you have a logic like this, I will want you to please expect it in this form, 288 something whatever. So I will want you to express it in that aspect. So how do you express it? So this is what you are going to be using, right? All these numbers on the top. So look at this element now. Add all the number on the top. 2 plus 2, so that's 4, plus 2 plus 6, that's 10, plus 2, that is what? 12, plus 5, that was what? So the atomic number of this element is 17, right? So if you want to write the electron configuration, it will be 287, right? So that's it. So if you look at this element now, this is, as a chemistry student, you know that this is chlorine, right? So it means it's an halogen, right? So even the answer is already here already. I told you that any element that ends with 7, they are group 7 elements, and I call them what? Halogens. So if you watch that video on periodic table, I've explained everything like this. So they said it has a completely filled p orbital. That's not right. Look at this p orbital. P orbital, I told you when I was teaching you that p orbital should have what? At least 6 on top of it. That is the maximum p orbital can take is 6, right? But look at this one now. This p orbital is not completely filled, so it means option A is wrong. Option B, it has 5 electrons in its outermost shell. Is that right? I'm talking of this outermost shell. So you can see it has 7 electrons on the outermost shell, and they said 5 electrons, so that's wrong. Option C, they said it belongs to the group 2 on the periodic table. So is this one group 2? I told you the number that end will determine the group. If you have something like 282 now, you can say that that is group 2, because that's the number at the outer shell, right? If you have something like 283, that will be your group 3. But how many periods with that? 1, 2, 3. That's period 3, group 3. Period 3, group 3. If you have something like 2, 3 now, so that will be group 3, period 2. That is the number of numbers you write that will determine. I think you guys are getting something. So that's just it. So it means this one also cannot be the answer. So the answer is it is an halogen. It is a halogen. So beryllium. So we did this in one live session that we did. I told you that beryllium is actually in group 2 elements. But on the periodic table, beryllium is in this place and aluminium is in this place. So they have what? They are diagonally placed together. So because of that, although aluminium is in group 3, right? And period 3, while beryllium is in group 2, period 2, right? Both of them, they will have a similar, because they are like diagonal to each other. I told you this thing, that we have something we call diagonal relationship. That this diagonal relationship means elements that are diagonal to each other, they will have like similar properties, right? So that's why they have a similar properties. So the answer is not they are both metals, they are not in the same group, they are not in the same period, because this one is 2 2 and this one is 2 8 3. So they are in period 3. This aluminum is in period 3, group 3. And beryllium is in group 2, period 2. So they are not even in the same group, not in the same period. So this one is wrong, not because they are both metals, not because they are both in the same period, but the answer is because they are positioned diagonal to each other. So look at this now. Look at this. I told you when I was teaching you on the bonds that we have something we call electronegative value. I told you that when you have an element, right? When you have an element that are diagonally, that their electronegativity difference is very large, right? The bond that will be formed between them is what I told you. It is a ionic bond. If the electronegativity difference, now look at this now. 3 is a very large electronegativity difference. How do we have something like 1.0? You can be saying it is actually covalent, a polar covalent bond, but the electronegative difference is greater than 2. So that's a very large thing. So it's either, so it is ionic bond, which is also called electrovalent bond. So that's the bond that will be formed between them. The answer is not metallic bond, it is not covalent bond, but the answer is the word ionic bond. So now look at these questions. They said how many protons? I taught you this also. I taught you this. I look at this element now. This is an element, right? This element now, you see it doesn't carry any electron, so it means your number of electron will be equals to your number of proton, right? So, and I told you that number of proton is normally in the bottom like this, right? So it means your number of proton, I told you, to be equals to number of electrons. So it means automatically this 27 is your number of electrons. So we have managed that. We have gotten the answer for what? Electron. And they ask us to find proton, electron, neutrons. That is proton, neutron, and electron. So we have gotten the electron already to be 27. The same thing with proton. I told you proton also will be 27 because that's the number below here. So the one on the top, I told you it is represented by mass number, while the number below is what? Number of proton. And because this thing is neither losing or gaining electron, so it will be equal to number of proton, right? Now for you now to get the number of neutron, so you just have to do is just say 60 minus 27, that will be 33. So that will be your number of neutron, right? So neutron now will be what? 33. So 27, 33, 27. So that will be your option C. I hope you guys are getting something. So that's just how to get the answer. So look at this question. They said number 10, the radioactive radiation used in studying the arrangement of particles in giant organic molecules is. So this thing is actually S-trace. So S-trace is what they use. If you are wondering that, how did they get the structure of some giant organic molecules like starch? Now, how did they get the structure of starch? It's actually due to the presence of due to the these radioactive radiations that they use to study how they arrange the particles are arranged. How do they arrange them? How is this carbon? Because you wonder some of the times in chemistry that how did they get all these compounds, that how did they know that starch contains carbon, hydrogen, and oxygen? So it's actually due to S-trace. So S-trace is what really helps us to do that. So that's why our answer is option C. So look at this question now. So this question is actually on isotopes. It's actually on what? Relative abundance of isotopes of elements. So look at this thing now. They ask us to find the relative atomic mass of these elements. They now give us the mass number of the first isotopes. They give us the second mass number of the third isotopes, second and third isotopes. Now this is the formula for this. Whenever you want to get the relative atomic mass of a particular compound, it should be mass of the first isotopes. So, and you know that this is the mass number times the relative abundance of the first isotope, and this is 92%, right? Plus the mass of the second isotopes, you know, that is this silicon, right? Times the relative abundance of the second isotope, that will be 5%, plus the mass of the third. There are some questions they will just give you only 2, right? So, but this one they gave us 3, so you have to do it till 3. And even if they give you 4, that will be M4 alpha 4. So now what is the relative abundance of silicon like that? So it will now be mass of silicon, the first one, that will be 28, times what is the relative abundance? 92%. What is 92%? 92 over 100 plus mass of the second one, that will be 29 times, what's the relative abundance? 5 over 100 plus, so the third one, so that will be 30 times 3 over 100. So that's just what we are going to do like that. I think there's an error in this question. It should not be 5. It should be 5%. So okay, it's correct. So this one is now be 28 times 0.92 plus 29 times 0.05 plus 30 times 0.03. So let's do that using our calculator. That will be 28 times 0.92 plus, sorry, I think to put brackets there. So when you are solving calculations, you have to be very perfect. And by the way, I'm not supposed to be using calculator because you guys are going to face questions, but yet you still have a calculator that you can still use in Utme, just that you must be very fast. And you don't forget your calculator you'll be using is not as good as this. So prepare for the so we have 28.11. So that was the answer. 28.1. So you can see the answer already. This is it, 28.11. So that's our final answer. So our answer is what? So the relative atomic mass of silicon is what? 28.11. So it does not have units. Just leave it like that. So look at this now. They said the nitrogen, I've taught you this also. The nitrogen obtained from air. When I was teaching you about nitrogen, if you watch the video for relative abundance, sorry, the descriptive chemistry of nitrogen, right? I talked about all these elements. So I told you that the element that this nitrogen that is obtained from air, it has a density higher than the one obtained from nitrogen containing compound. Why? Because all those, I told you that in the air we have nitrogen, and nitrogen makes what? 78%. In the air we have oxygen, 21%. In the air we still have carbon dioxide, 0.03%, right? And the rare gases is what? And all those noble gases, they are 0.97%, right? So now this is what they do in fraction when you are obtaining nitrogen from air. Oxygen and carbon dioxide will be removed, but these rare gases, you cannot be able to remove them. So what it actually means now is that these rare gases will not combine with this nitrogen. So it means when you are now obtaining the nitrogen from the air, right, you will be able to remove only oxygen and carbon dioxide. So it means this nitrogen will be contaminated with what? With these rare gases. So it means it will not be heavy than the one you obtain from compound. Because the one you obtain from compound will be more pure than the one you obtain from the air. Because these rare gases, there's no way you can remove them because they are not reactive. It's because oxygen now you can use, I think, alkali pyrogalo or heated copper. You can use it to remove oxygen. And carbon dioxide, I told you can use sodium hydroxide or use potassium hydroxide to remove it from air. But these ones, you cannot remove them. They are not really reactive. So that's why the answer is option C. So let's go to number 13. So water is said to be temporarily hard when it contains. So I told you that the things that cause temporary hardness is the salt of this compound, CaCO. So these are the things that causes, and so these are the things that causes what? Temporary hardness. So I've told you. So these are the ones that cause what? Temporary hardness. And what are temporary hard water? So they are the water that you can remove. You can remove their hardness by simple boiling. So if I ask you, how can you control? How can you soften a hard water, a temporary hard water? So all you just have to do is what? You boil them. So I've taught you this also on the video for water. So you can go and watch it if you still have the time. So watch it. Now, what are the ones that causes hard permanent add water. So it is CaSO4 and MgSO4. If you look at some textbooks, they will give you more than this. They are more than this, right? But just to be precise for your level, just this, right? So I don't want to be adding too much stuff for you that you not be feeling overwhelmed. So this type of water, you don't really need this type of hardness. You cannot remove them by simple boiling. You have to either add washing soda or you use a method called ion resin. So I taught you that in that video. So I cannot be writing everything again because of our time. So the answer here is what? Option A. So these are the compound, that is calcium calcium hydrogen triisocarbonate 4 and magnesium hydrogen triisocarbonate 4 salts. So these are the ones that causes permanent temporary hardness. Now on exposure to the atmosphere, so I told you this, that there are some salts, when you expose them to the atmosphere, they will lose some part of their water crystallization. While we have some salts, when you put them in the atmosphere, they're going to absorb moisture to form solution. I still say there are some salts that when you put them into the atmosphere, they will absorb moisture, but they will not form solution. The ones that will absorb moisture and will not form solution, we call them hygroscopic. The ones that will absorb moisture and to form solution, they are called deliquescent substance. The ones that will lose part of their water of crystallization is what? Efflorescence compound, or the process is now called efflorescence. So the process on exposure to atmosphere to the atmosphere, a hydrated salt loses its part of water of crystallization to become anhydrous. For example, now maybe this compound now, CuSO4.5H2O, you now expose it to the atmosphere. If this water now gets removed, it now becomes CuSO4, right? So this process is actually called what? Efflorescence. So that's option A. So number 15. So I don't think there is answer for this. So, but let me just teach you how to do it. The past question I'm using already has already said no answer. But let's try to do it. I just want to see. You know, this is a question on solubility, and it's not something like to just leave and do like that. So they ask us to calculate the solubility of the solutes in mole per dm cube. Look at what they did. The answer is now in gram, so that's not right. So that's why they said this question does not have what? It has no answer. So, but let me teach you how you're going to do it whenever you come across this type of question. So look at this question. They said 16.55 gram, right? So of lead 2, right? Triisonitrate 5. Now, how do you write this compound? Lead 2 triisocarbonate 4, 5 is like this. PPNO3 into brackets 2. So that's how it looks like. So this, because if you don't know how to write the compound, there's no way you can solve this question. So they now said 16.55 gram of lead 2 triisonitrate 5 was dissolved in 100 gram. Now I told you this when I was teaching you solubility, that when you dissolve something is 100 gram, is the same thing as 100 cm cube, right? So 100 gram under this thing is the same thing as what? 100 cm cube, right? So what we just want to do is that I want to convert this gram right, to gram per dm cube. So I'll just say this one is 1000 cm cube, and then I will say this is x, right? So let's cross multiply. So we have 100x is equals to 16.55 times 1000. So divide by 100 divided by 100. So what do we have? So our x will now be 165.5 gram per dm cube. So why am I doing this? We are going to know now. Because the reason why I'm doing this is because I can use a formula called conc in mole per dm cube, because we are looking for what? Conc in mole per dm cube. And conc in mole per dm cube is equals to conc in gram per dm cube, which is this one, over molar mass. And what is the molar mass? So molar mass means they've already given us all the values already. You just find the molar mass of this compound. So molar mass of PbNO3 will now be PbNO3. So that will now be what? It will now be 207 plus, don't forget there is bracket 2 here. So you begin with 2, right? Then what's the molar mass of nitrogen? 14. Molar mass of oxygen 16 times 3, like that. So we now have 207 plus 2 into 14 plus 48. So we now have 207 plus 2 into 62. So what do we now have now? We have something like, so we have 207 plus, so that would be around 62 times 2, so that is 62 for 124. So we have 331 like that. So that's our molar mass, Abi. So look at it now. So we have 165.5 over. So our molar mass is 331. So let me do that. Though we may still get the answer, but I think they make mistake in the units. So 165.5 divided by 331. So you can see we get 0.5. So answer here is what? 0.5 gram. Although they did not put the unit, is not right. The unit should be in mole per dm cube. So that's why they said no answer. So there's actually answer here. The only problem they make is the unit. That's not right. Because they themselves, they've already said in mole per dm cube. Or even if they, because they have said mole per dm cube, they don't need to put any units there again. So the answer is option D. So 0.5. So we are done with that. They now said, now look at this. When I was teaching you some things about this, you will just be looking at me. Now I was teaching you that bit. I taught you this in a video in the chemistry group in matter, that the dispersion of liquid in a liquid medium will give what? We give what? What is liquid dispersed in liquid? Oh yeah. Liquid dispersed in liquid. I think I've taught you this already. Oh yeah, just try it. I taught you this, that aerosol, that is liquid dispersed in gas. Gel, that is a solid dispersed in liquid. Fog, what is fog? Fog is like gas. That's to do with gas. For emulsion is now what? Liquid dispersed in liquid. So that's the answer. So emulsion is what? This liquid dispersed in liquid. The answer cannot be gel, because gel is liquid dispersed in solids. That is a solid dispersed in liquid. You know, when you want to, gel is like, I don't want to use Yoruba. It's like amala. I don't know if you have ever seen them doing amala. So amala, you pour elubo inside the hot water. So that is liquid, right? Elubo is solid. So that is solid dispersed in liquid. That's what I'm using. And for aerosol, when you want to like remove some herbs, some wheat around your surroundings, your father will say you go and buy some soap, some chemicals, some herbicide. You use it, you put it inside a particular jack, you'll be jacking it, then you'll be spraying it. So that's liquid, right? What you are spraying out is in form of gas. So that's aerosol. That's liquid dispersed in gas. So the major and most effective way of controlling pollution is, so how can we prevent pollution? Option A, improve machinery so that the substances released from the combustion are less harmful. Is this we should improve machinery so that the substances released from combustion are less harmful? Pass strict laws against it by individuals and companies. Option C, educate people on the causes and effects of pollution. Option D, convert chemical waste to harmless substances before releasing them into the environment. So what do you think will be the answer? What will be the answer? So the answer is you educate people on the causes and effects of pollution. So that's it. But this question is actually is based on what you think is right according to your own perspective. Some people can say let's convert it to harmless substances. Some people can say we pass strict law against it. So it depends. So number 18, the basicity of CH3 COCOH is what? So they're asking us that. So I told you this when I was teaching you acid, base and salts, that don't count this hydrogen here as it cannot release this hydrogen. It can only release this hydrogen, right? So I told the basicity of an element is the Okay, hold on for me. So I told you when I was teaching basicity that basicity is the what is the number of irreplaceable hydrogen atom in a particular compound. Abi? So I told you that, right? So the thing is that it can only replace this hydrogen, and that's why when you react CH3COH with NaOH now, it can only react, it can only replace only this hydrogen. It cannot replace this hydrogen. So you'll be getting CH3COO Na plus H2O. So you can see that it's only replace this hydrogen. It cannot, it can only replace this hydrogen, right? So that's why we say the basicity of ethanoic acid. This is ethanoic acid. So the basicity of ethanoic acid is what? Is 1. But for citric acid now, citric acid is tricarboxylic acid. The reason why the basicity of ethanoic acid is 1 is because ethanoic acid it's monocarboxylic acid. That is, it has only one COOH. Adebins is the dicarboxylic acid. It's going to have basicity of 2. So tricarboxylic acid, like citric acid, we have basicity of 3. So now the color of litmus in a neutral medium is, so this question is one of the questions they normally ask. That was the color of, I think I told you one of the videos like that the color of litmus paper in a neutral medium. So what do you think would be the answer? So you know that color of litmus in acidic medium is what? Is red. So now what is the color of, so you can just pause the video and try it. So what is the color of litmus paper? Litmus in a neutral medium. Yeah, what is the answer? Is it purple? Is it pink? Is it yellow? Is it orange? The answer is purple. But I've taught you this. I think one question like that, I taught you that the color is purple, and the color of litmus in alkaline medium is blue. In basic is also alkaline. So acidic medium, I told you the color is what? Red. So neutral is actually purple. So at times they may just say, instead of saying neutral, some of the times they may just say, what is the color of litmus when the pH is 7? Please, they can be somehow tricky some of the times. They may say when the pH is less than 7. You know that when the pH is less than 7 is what? Is acidic. When the pH is greater than 7, it means the solution is actually what? Basic or alkaline. So they can use any type of they can use any type of what? Any type of thing. You know, the color of litmus paper, I think you guys should know, it's just like a purple, something, somehow like this. So, because litmus solution is actually made up of purple dye, which is extracted from lichens. So it's actually a natural indicator, and it is used to indicate the presence of an acid and base or base. So let's look at it. Now, what's the mathematical expression of pH? So now it's now left for you to know the mathematical expression of pH. Now, you need to know that pH is different from pOH. pH is negative logarithm of H plus into base 10. That's what I taught you, right? I also taught you that pOH is minus log OH into minus this, right, into base 10. Now look at what they do here. This one is actually what? Hydrozonium ion. And I told you when I was teaching you pH that hydrozonium ion is the same thing as H plus. So it means pH can also be equals to negative logarithm of what? Of H3O plus into base 10. So it's still the same thing, right? So the answer will now be, so now this one cannot be the answer because they asked us pH, not pOH. I didn't mean they said pOH. Now you can go and say this, but they said what? pH. Do you get? Now you'll be wondering, why is it that they don't put minus in front of it? The reason why they don't put minus is that, so the answer here, without even telling you, is option B. Why is it that they don't put minus? Now this is the reason why they don't put. Look at this minus here. It's just like saying. Let me try to explain to you. You know, when I was teaching you logarithm, I told you that, I think in mathematics, I told you that a log x is the same thing as log x raised to power a, right? So the same thing with these two. So if you have log 1 over x, log 1 over x is the same thing as log x raised to power 1 minus 1, right? So bring this minus 1 to this side. What will it become? To become minus log x. Do you agree? So the same thing with this one too. So you just bring, so if you try to, let me say this h3o plus, let me represent it with a. It will now be ph equals to minus log base 10 into a. I'm representing it with a. So it will now be ph now equals to, bring this minus 1, bring it to the top. It will now be log base 10 into a raised to power minus 1. Do you see now? Now this a, now let me return it back to h3o plus. It will now be ph will now be equals to minus, sorry, it will now be equals to log h3 0 plus into what's minus 1, right? So it's the same thing as log base 10 into 1 over h3. You know, I told you when something, anything is raised to power minus any number raised to power minus 1 is what's 1 over that number. So that's what they did. So it's not something that's just be what you don't want the but sir, you thought is minus. So you can see Utme can bring question in any dimension. So that's why you have to be grounded. Because when I firstly saw the questions, I was so somehow surprised that these things you don't have minus. But it was when I was just looking at it critically and I noticed that they have used some mathematics trick. And that's why as a student you need to be very, very grounded. So which of the following salts will turn blue litmus paper red? So all these salts that you see here is only one of them that is acid. Look at the salts. Which of them do you think is an acid salt? So it's actually look at this. Anything that will change blue litmus paper to red, it means that thing is acidic. Right? Now look at the option. Which of them do you think is an acidic salt? Look at this. Sodium trihydroxynates 2 is not acidic. But look at this one. Sodium triisocarbonates 4, that is Na2CO3, is not really acidic. Sodium chloride hydroxide, I don't even know that one. Zinc chloride hydroxide. Okay, this is it. Zinc chloride hydroxide is zinc OH into brackets chloride abi. So this one also is, will be basic to litmus paper. This one will also be basic to litmus. But look at this potassium hydrogen. So potassium hydrogen tetraososulfate 6. So you look at this. This is an acid salt. So when I told you that acid salt they behave as acid, so it means it's going to change what blue litmus paper to red. So that's the answer. So look at this, another question. So look at this question now. They said in the reaction above, the oxidation number of the reducing agents changes from. Now the question now is, which one of the following do you think is the reducing agent? So the answer is this zinc is the reducing agent. Why is it that it's the reducing agent? The oxidation number of zinc here is 0 because it's not combining with any elements. So I told you when an element is staying on alone, the oxidation number will be 0, right? So now, but look at this. When it gets to this side, the oxidation number of zinc here is actually +2. Why? If you're asking me how did it become +2, it's because this zinc is 2 plus, right? And this SO42 minus also is 2 plus, right? 2 minus. So but when these 2 and 2 they come to this side, they are going to cancel each other, right? They're going to cancel each other. So that's how we are able to get zinc SO4. So it means it carries 2, right? So they now ask us that what will happen, that is how is the oxidation number of the reducing agent changes. So it changes from 0 to +2. So that's the answer. So you can see from 0 to +2. All this +1 is wrong. The answer is 0 to +2. So we'll go to another question. So look at this now. They said the oxidizing agent in the reaction is, so which of the following do you think is the oxidizing agent? Look at this. This is the carbon. So carbon here is, it has an oxidation number of 0. But when it gets here, it becomes what? You can see carbon 2 oxide. So what is the oxidation number of carbon 2 oxide? -2. I want to look for oxidation number of what? carbon in this compound. Right, so you can see the oxidation number of carbon here, it goes from 0 to +2, right? Is this carbon a reducing agent or oxidizing agent? So it's actually a reducing agent. But look at this water here, right? The oxidation number of water here is +1, right? But when it gets here, right, it becomes 0, because I told you that when an element is starting alone, right, the oxidation number will be 0. So the oxidation number of hydrogen here is 0. But here, because hydrogen is combining with water, it's combining with oxygen, right? And you know that oxidation number of hydrogen is what? Is 1 normally. Oxidation number of oxygen is -1. I told you the exception when I was teaching you oxidation and reduction, right? So the oxidation number of hydrogen here is +1, but when it gets here, it becomes 0. So it means it's reduced. And I told you oxidizing agent, they reduce. Reducing agent, they oxidize. That is, oxidize means they increase in oxidation number. So oxidizing agent means they decrease in oxidation number. So you can see that it's actually decreased from +1 to 0. You know, when I was talking on this, it's actually what it increased. So that's why we say call it a reducing agent. Though that name some of the times is somehow confusing that they call something reducing agent, and its oxidation number is still increasing. The reason why they call it reducing agent is because it will cause the other one to reduce in oxidation number. So that name is not really for him, right? For example, if they say someone is a marketing agent, that person is marketing for a particular company. He's not marketing for himself. So the reason agent they are talking about is not, it doesn't mean that person is reduced. That person only causes reduction for his counterparts in that reaction. But he himself, it himself will be what? Will be oxidized. So the oxidizing agent there is what? Water. So option C. So calculate the quantity. So this is a question on that's a question on the electrolysis. So calculate the quantity of electricity in coulombs required to liberate 10 grams of copper from a copper compound. So look at this. So copper is a 64. So they said calculate the quantity of electricity. So this is just the formula. Just say M is what? Equals to Q, right? Sorry, let me just say Q is equals to M. Now what does Q represent? Q, you know, when I was teaching you, Q represents the quantity of charge, Abi. Look at it. They said we should find quantity of charge, Abi, quantity of electricity in coulombs. So this is what we are looking for, right? So how do you do that now? And you know that copper that they are talking about here is copper 2 oxide, right? So it means your farad here is, I told you when something is copper 2, if it is aluminum 3, it will be 3 farad. If it is copper 2, it will be 2 farad. So it will be 2 farad here. What's our mass like that? So it will now be equate to the molar mass of copper. That will be 64, right? So now what is this? They said we should find quantity of electricity. Okay, let me be fast. They said 1 farad here is what? 1 farad here is what? 96,500. So it means 2 times 96,500. It will now equate to the molar mass. So that will be 64. Now they now give us another mass, which is 10 grams of copper. So that one will now be written below this molar mass. So this quantity of charge that we're looking for, you write it here. So then you cross multiply. So now the 64Q is equals to 10 times 2 times 96,500. So over 64. So Q will now be equals to, what will be your answer like that? Sorry? So 10 times 2, times 96,500 over 64. So what do you have now? That's 30,156. So 30,156. So you can see it's already in the answer already. The answer is option. So it is actually in coulombs. So So the answer is, but they already said in columns already. That's why they don't put units. It's not that it doesn't have units. I think you get now. So look at this question now. They now said how many farad of electricity is required to produce a 0.25 mole of copper. So this type of question is actually a little bit tricky, but it's actually very simple. You know that I told you that normal copper is Cu2 plus Ab. And I told you that 2 farad now, it means it will give us 1 mole of copper, right? That's what they are trying to ask us here, right? So now they now said instead of having 1 mole of copper, they now say it's now 0.25 mole, right? So it means we are going to look at the number of farad that's going to give us. So let's cross multiply. So we have 0.25 times 2 farad is equals to 1, which is our x. You know, we are cross multiplying the x times this, 0.25 times this. So 0.25 times 2, that's a 1 over 4 times 2, that is 0.5 farad. So the answer is what? 0.5 farad. So what is the answer? 0.5 farad. So you can see this thing is not, once you know the logic like this, you are good to go. So our answer is 0.5 farad. So look at this. They say Z in the diagram below represents. So look at it. I've taught you this already. That's when I was teaching you about all those heat of reaction, whatever. So this is it. This Z is the what? Yeah, what was the answer? What is this Z? Oh, yeah. So the Z is actually what? Heat of reaction. So that's the answer. So it is the heat of reaction. So all this Y now is what? The activation energy. Okay, I'm not really sure if it's activation energy. I think activation energy should join with this. It should join with this reactant, but anything should be. You know that I taught you all these things. That if you use a catalyst, it should reduce the activation energy. So things like that. I told you the top here will be activated complex. This X on the top is to be activated complex. I didn't really ask. So I told you this one can be activated energy, but I'm not so sure. So this is your product and this is your reactant. So that's just about the reaction. So nothing so special. So if you see something like that question, you are running away from it, then you don't know what you are doing. They said if the change in the free energy of a system is so, that's free energy change, delta G minus 89 joule per mole. So and the entropy change is represented by delta S, that is 10 joule per mole per Kelvin, right? So they now said at, so that will be your temperature, 25 degrees Celsius. They now say we should find the enthalpy change. Now what's the formula for this actually? Oh yeah. Do you remember the formula? So delta G is equals to what? Delta H minus T delta S, if I can still remember. So that's the formula. So what's my delta G? Minus 8999. What's my delta H? So my delta H is what I'm looking for. They said enthalpy change. I told you enthalpy change is denoted by what? Delta H. Free energy change is denoted by delta G. Entropy change is denoted by delta S, right? So what's my delta H now? My delta H is what I'm looking for. Now what's my temperature? I told you you have to convert to Kelvin when you're under this topic, except when you are under all those specific capacity like in physics, and you don't need to convert. So all those, so delta S was 10 joule. So just say 899 now. You now equals to delta H minus 2980. So you bring this to this side. So your delta H will now be equals to what? Minus 899 plus 2980. At the end of the day, what are you going to have? 2980 plus 2980. At the end of the day, what are you going to have? 2980 plus 2980. 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 2980 we are going to have, we're going to have minus 899 plus 2980. So what do you have? 2008. So plus 2081. So your delta H is what? Is plus 2081 in joule per mole. So what did I tell you? The implication of this, when delta H is positive, I told you the reaction will be what? Endothermic. But if it is negative, the reaction will be what? Exothermic. So I've taught you this already. So it will be absorbed if it is endothermic, and exothermically it will be liberated. So all these things are things you need to know. You can see all these things we have done, they are coming out one after the other. So now the equilibrium constant is very large. Okay, sorry, they asked us a question here. They said in the equilibrium reaction, which of the following conditions indicate that maximum yield of the product will be obtained? So what would be the answer? Is it that the equilibrium constant will be very large, or the delta H minus the T delta S will be equal to 0, or the delta H will be greater than the T delta S, or the equilibrium constant is less than 0? So the answer is the equilibrium constant is very large. So that's what will tell us that the reaction is giving us maximum yield. So that's why it's good to solve past question. So look at this now. In a reaction, in a chemical reaction, the change in concentration, I give you like 3 definitions for rate of reaction. I told you the volume over time, different types of definitions. So in a chemical reaction, the change in concentration of the reactants with time is what? Rate of reaction. So I've taught you that some of the time, most of the time will always be, all the time, whenever you're talking of rate of reaction, time will be below. So it is concentration over time, the rate or the change in concentration over time. That's rate of chemical reaction. So that's just it. So look at this now. This is another question. They said, what happens to the reaction above when the hydrogen ion concentration is increased? That is this place. What is going to happen? It means you are increasing the products. So what do you think is going to happen? You are increasing the products. So now this is what's going to happen. I told you when I was teaching you about this thing that when you are increasing the reactants, the products will be increasing. Now what you are now doing is you are now increasing the products. It means the reactants, the products will be reducing. The products will be reducing. The equilibrium position will be favoring the what? The backward reaction. This is what I told you. If you increase the concentration of the reactants, the equilibrium position will increase towards the right. If you increase, similarly, if you increase the concentration in the products, right, the concentration in the reactants will be what? Will be increased. So the same thing with this now. So as you increase the concentration of this hydrogen ion, right, the equilibrium position will shift to this left side, right? So it means it's going to be increasing the yield of this reactants. So these reactants will what? They will increase in number. So the equilibrium position will shift to the left. You know, it's a backward reaction, so it's in 2 ways. So that's why they said the equilibrium position will shift to the left. So that's the answer. It will not shift to the right, because what you are the concentration of the place, if you are increasing the concentration of the reactants, the products will increase. So and as the product is increasing, the equilibrium position will shift to the right. But if you are increasing the concentration of the products will favor the reactants. So it means the equilibrium position will shift to the left. So I think you get the logic like that. So that's just it. So I think we are done with that aspect. So let's go to the next one. So which of the following will liberate hydrogen from a dilute tetrasulfate acid? So I told you that anything that is higher than a hydrogen in the electrochemical series is going to liberate hydrogen. So look at this. Popular science can make all zoo in the low humid country more satisfactory. Good. So look at this now. Copper cannot displace hydrogen, cannot liberate hydrogen from dilute tetrasulfate acid. Although lead is higher than hydrogen, in the electrochemical series, but yet we will prefer using magnesium than lead, because lead is a little bit very close to hydrogen. So hydrogen can still fight lead, and told him, you are just 1 year older than me, I will not allow you to liberate me from this acid. So lead can still fight or wrestle with hydrogen. So hydrogen can still wrestle with hydrogen. Hydrogen can still wrestle with lead, so thereby not allowing it to liberate it. So we have to go for magnesium, because magnesium is a little bit, is very older than hydrogen, so you will be able to liberate hydrogen from it. That's why we go for magnesium. So this is the reaction for the equation. So this is how it should look like. So this is what we mean by if something displaces something, liberate hydrogen. What it's doing is that it is going to remove hydrogen from this acid, right? It's not going to take the place of hydrogen, right? So you can see that is like cheating. It's like eating your younger brother food. So that's just it. So you can see it's like, but lead can still fight with hydrogen and say, no, you will not collect this food from me because this is lead. If you don't know symbol, so you can see. So that's why we go for magnesium. So look at this now. I told you this. I think I draw this diagram for you when I was under chlorine. So this is the laboratory preparation of chlorine. So if you don't see it very well, this is they wrote chlorine here. Here they put conc H2SO4 there, and here they put water, and here they put conc HCl and KMNO4, right? So that's what they put here. Now they now say, what's the function of this conc H2SO4? So this conc H2SO4, the function is to what? What's the function? The function is to dry the gas. You know, I told you that in chemistry we use H2SO4 very well. I told you in organic chemistry, most of the time, if you don't, they use it for dehydrating agents, as a dehydrating agent, right? They use it as a catalyst in organic chemistry. That's in esterification, right? They use it as a catalyst. Now, in this aspect, in inorganic chemistry, they use conc H2SO4 as a what? A drying agent. So the drying agent here is what? Is conc H2SO4. So it is actually the one that will dry chlorine gas, right? Because chlorine gas, if you don't dry it, it will not be able to be like absorbing, so it will contain some moisture, that is some water. So it is that conc H2SO4 that will remove some water, because conc H2SO4 is actually hygroscopic in nature. So it is what? Hygroscopic. If I ask you why is it that conc H2SO4 is able to dry a gas, is because it's what? Hygroscopic. It can absorb moisture from a particular thing. So any drying agent that you ever heard about, just know that that drying agent is actually a liquescent substance or hygroscopic substance. So if I ask you which substance is used for as drying agents, it's actually a substance that is deliquescent or hygroscopic. So H2SO4 is hygroscopic. So that's why we consider using it as what? Drying agents. So the gas that is removed by the water. So which gas? Now, they're asking of us for the function of this water. Now, which gas do we remove from this water? So it means that will be the impurity that is in the what? In the when we are producing water, when we are producing the impurity of chlorine, when we are producing doing the preparation of chlorine gas. So the answer is just the function of that water is to remove what? HCl. So that's the answer. So that is because HCl, we are producing that chlorine from the HCl. So at that HCl we want to like it will want to leave the main reaction mixture, but that water will help us to stop it. So number 33, fluorine does not occur in the free state. I told you fluorine is highly reactive. In fact, when I was talking about the halogens, I did not even choose it. I don't think I choose it as representative element. It is very, very, very reactive. It's very, very reactive. So because of that, you cannot find it free in nature. It's very, very reactive. So fluorine does not occur in free state because it has what? A high reactivity. So inert, never. Fluorine is very, very reactive. So inert means something is not reactive. So and that's not right. So that's why we don't go. So of course it belongs to the halogen family. So that's not what they're asking us. They're asking us why is it that so some of you can quickly go and choose and it belongs to the halogen. No, they're asking us something that is specific. That is the main reason why it is not found in free nature. So now look at this now. In the extraction of sodium from fused, so I taught you this in electrolysis. In the extraction of sodium from fused sodium chloride, the anode is made of platinum because A, sodium is formed at the anode, the chlorine is formed at the anode, sodium does not react with platinum, chlorine does not react with platinum. So what is the answer? They said in the extraction of sodium from fused sodium chloride, the anode is made up of platinum. Now this is it. If you want to extract sodium chloride, right? If you want to extract sodium using the fused sodium chloride, so it means this was going to be happening. So I taught you this already in electrolysis. So these ones now, they will go towards the anode, right? Do you get me? These ones, they will go to cathode, right? Now what is that telling us now? They now say the anode is made up of what? The platinum. So what is that telling us? The answer is the sodium does not react with platinum. That's why we use platinum as the anode. So that's why we use it as anode. So let's continue. So a compound that you can see what I told you when I was teaching you about the flame test. I told you that anything, calcium, a compound that gives a brick red color to a non-luminous flame is what? So I told you flame test that I think the color for copper was bluish green. So bluish green. That of sodium in flame test is what? Golden yellow. So I taught you this. So you can see they normally ask. I told you brick red, calcium. I don't know. They like asking about it. So the answer is calcium ions. So it's the one that gives us brick red color. 36. So calcium ions. So you can see now. So that's the answer. So in the electrolytic extraction of calcium from calcium fluoride, the cathode is what? Now what's the cathode? When we want to extract calcium, so the answer is the cathode is platinum. So please go and read that extraction of metal very well, and I think I made some videos for that. So in those descriptive chemistry, so I make it. I think I made some of them. So the cathode is made up of what? The platinum. Oh, sorry. The cathode is made up of iron. Sorry. So now number 38. A few drops of NaOH solution was added to solution. Okay, hold on. So the cathode is iron rod. Yes. The cathode is iron. I want to be so sure before. So why the graphite? So iron will be used as the cathode when you want to do in the extraction of the calcium. Please take notes. Why your graphite will be your anode? Please take notes. So please take notes. Don't forget in the electrolytic extraction of calcium. What will be our anode? Iron. cathode. Our anode will be graphite, our cathode will be iron. So please try to take note of that, please. And this one too, make sure you, that's in the extraction of please, all these things, please, they just, it's like some of these questions they want to put it there so that they will not want you to get 100. And I tell you very well, I think people get 99 in physics and chemistry. Even in mathematics, people can get it. So I'm challenging you guys to be serious. I'm challenging you. I'm challenging you. So actually, I made a mistake here. I was looking at it the way I was doing it. There's actually a mistake here. Sorry. This answer is actually chlorine does not. Chlorine is going to. I told you that cathode is in what? The anode is the platinum, right? The anode is in what? The platinum. The chlorine is going to the anode, right? And the anode is platinum, right? So the reason why we use platinum as the anode is because fluorine will not react with platinum. That's why we go for it. So that's the answer. So sorry for that error. Now a few drops of NaOH. Please, all this practical chemistry. When I was teaching you, some of you are like, you just thinking that all these things are not important. Do you see now? Though I did not really go through them very well, but I just like give you an overview that all these things they normally come out to practical chemistry, all those qualitative or quantitative analysis. So you can see what they say there. They say a few drops of NaOH solution was added to an unknown salt, right, forming a white PPT, so which is insoluble in SS solution. They now say the cation present is what? So what's your answer? Oh yeah, what's your answer? Let's try it. So although this is not a live video, let's have to. Oh yeah, what's the answer? So the answer is calcium. Calcium is the one that will give you something that is not soluble in SS. So it's calcium. The other ones, they will be soluble in SS. But calcium is insoluble. So the answer is calcium. So we are now moving to number 39. So we are progressing. They now say the general formula of alloalkanes. Now I did not teach you this. When I'm talking of alloalkanes, it's like compounds like this, CH3Cl. So you can see, and I told you that methane is CH4b. So what is this one? This one is actually chloromethane, something like chloroalkane, right? Now what is the formula for the alloalkanes? I did not teach you this, right? So this is the formula. That is CnH2n. The formula for alkane is CnH2n plus 2. Abi. See, this is the for alkane, Abi. All you just now to do now is you remove 1 from this. You now make it X. It will now be CnH2n plus, you remove 1 from 2. So now become 1, Abi. For you now to get alloalkane, you now represent that 1 that you remove. You represent it with X. So that's just what you do. So this is the formula for the alloalkane. So option A is not correct, option B is not correct. So let's go to the next place. So that's where we will see it. So you can see it's already option G, so that's the answer. So number 39. So number 14 now, look at the first number 14. I told you how you pass to nomenclature. So look at this. So here now I told you you will start your naming from functional group, where your carbon is near to the functional group. So you start from this first carbon. That will be 1, or should I use another color so that you can like know that? Okay, let me use blue. I want to use a very thick color. So 1, 2, 3, 4. Look at it now. So 1, 2, 3, 4. So now what is it telling us? So you start your naming from alphabetical order. So don't go and be saying 2-chloro. No, you start from bromo, because bromo is alphabetically. You firstly see bromo before chloro, right? So you start with 3-bromo, comma. No, you don't put comma, hyphen. So now be 2-chloro. I think you should understand why I don't start from this side. The reason why I don't start from this side is because this side is not close to substituents, right? So that's why I don't start here. So that's why I start. And also this is the functional group. So and this functional group should have power than the substituents, right? So that's why I start from this place. And this is actually a functional group for alkano. I told you this is the mirror formula. HO is the same thing as OH. So don't be confused. I think I've explained that over and over again. So now what is the formula now? So it will now be 3-bromo, 2-chloro. So how many carbon do we have? 4 carbon. So that will be 3-bromo, 2-chloro, butano. So that will be your answer. So 3-bromo, 2-chloro, butano. So that will be your answer. So that will be your answer. So we are starting with alphabetical. Okay, hold on for me. I want to confirm something. So we have like 10 more questions to do. Okay, that's the answer. So that's the right answer. But you can see some people, they go and choose 2-chloro, 3-bromo, butano. It's actually wrong. According to the rule, so you should start something with that's alphabetically before you go to ABCD. I think you are not in primary school. B comes before C, so you choose this also. Although this also is correct, but it's not really so reasonable. So you start with something that is, although 3 is higher than 2, but when you are doing this thing, bromo should come before fluoro. So that's the answer. So let's continue. So the cannot obtained from the production of soap. I told you when I was teaching you about saponification. Sorry, I need to change this color. So I told you that saponification, it will lead to production of what? Soap and what? Glycerol. Right? So that's the alkanol that we produce from in the production of what? Soap. So alkanol is what we produce. So the alkanol we produce is what? Glycerol. And this glycerol is also called what? Propane 1,2,3 triol. Propane 1,2,3 triol. So that's the answer. The answer is glycerol. So and for us to now, they may ask you some question that how do you remove soap? How do you sort out? There's something we call sorting out process in soap production. So sorting out process is actually carried out by sodium chloride. That is, you add salt to it. When you see people making soap and they are adding salt on a part of the solution, so what they want to do is that they want to increase they want to decrease the solubility of that salt, so that the salt will be floating and they can easily remove that salt as that soap from the mixture. So ethane is passed through a hot tube containing organonickel catalyst to produce what? I told you ethane is what? C2H2. So when you pass it over nickel catalyst, what did I say is the type of reaction? I told you it is polymerization and it will lead to formation of benzene. Right? So let me check where they ask first. So you can see already. So that's what it leads to. To do to formation of benzene. So that's just it. So let's go to number 43. Due to the unstable nature of ethane, it is stored in what? So where do we store ethane? Ethane is very, very, very reactive and it can even explode. So because it's unsaturated, I told you, I give you an illustration that ethane is very hungry, so you want to eat. So it will be very, very violent. The way you normally behave to your younger brother when you are hungry. So the same way, that's how ethane also behaves. So for us to now preserve ethane, we normally store it by dissolving it in propanol. So that's what we do. I think I taught you that also in that video. Now the process of converting starch. When I was teaching you ethanol, the properties of ethanol, I told you that the process we can also use for production of ethanol is by converting starch to we firstly convert it to diastase. After diastase, we convert it to what? Maltose. After maltose, we convert it to glucose. And finally, after getting glucose, which is 6 is H12O6, we get what? Ethanol and CO2. So this is what we finally get. So this is how we produce ethanol. Now, what's the name of this process? I told you this process is actually called what? Fermentation. So that's the process. So the answer is option C. So, and the enzyme we use here is zymes. So this is not diastase. So the process of the enzyme that work when we convert starch to maltose is diastase. Yes, so the enzyme that now work when we convert maltose to glucose is now what? Maltase. Why the enzyme that work last is now zymes. So the polymer used in making carrier lights. So what do we use in making carrier lights? So which polymer do we use in making what? Carrier lights. So I'm waiting for your answer. So just try to. So you can see uses is very, very important. I told you when I was teaching you organic chemistry, uses is very, very important. So you can see they're asking us uses. So please, all the uses I did not write down in that organic chemistry, make sure you don't say because I just say it with mouth and you just say the B of teacher just say it with his mouth. He did not write it down, so it's not important. If you say that, you're on your own. No? You're on your own, because organic chemistry is, you can ask any question on organic chemistry, and if you are the person that have been preparing for it, and at the end of the day, they're not going to ask something that is very, very difficult, it's not that it's difficult. The one that is not serious. So the answer is actually what? The polymer used in making car rear lights. Oh yeah, what's the answer? So the answer is perspex. So perspex is what we use in making car rear lights. Perspex. So look at this question now. You can see this is esterification. This reaction is what? Esterification. Right? So now look at this reaction. They said, sorry, this reaction is esterification, but this is actually the backward reaction of that reaction. So this is hydrolysis. The forward reaction is hydrolysis here. Why the backward is now what? Esterification. I think you see what they did. They bring the reactant, they bring it to the product. Why they bring the product to the reactant? So if you are a person that you function, you read it very well, you know what I'm saying. Now they now say, what's the purpose of that H plus in the reaction above? So what's the function of that H plus? So H plus, you've been looking at what did they mean by H plus in the reaction? H plus did not write it in this reaction, but H plus is actually functioning. So what's the function of the H plus? So I'm asking you. So the function of the H plus is, when there's increase in concentration of a particular thing, is to increase the yield of the product, right? So it's the function of H plus is to increase the yield of the products. So that's just basically. So we're almost done. So number 47. So this one is actually a question on molecular form. I'm so happy that all these things that I did not really teach you in the syllabus, they are that I did not really touch. They are actually in these videos. So I'm going to use that to. Though I teach you this empirical formula, I taught you empirical formula. I taught you molecular formulas in that stoichiometry video I sent you. So I'm happy that I'm still going to re-teach you again. So even if you don't understand, you'll be able to know them. So you'll be able to know them. So sorry, the purpose of H plus here is to increase the rate of hydrolysis. So that's the purpose. The purpose of H plus is to what? Increase the rate of hydrolysis. This H plus is to be gotten from this H2O. H2O is made up of H plus and OH minus, right? So this H plus inside this water, when it's increased, right, it will increase of this this forward reaction I told you is hydrolysis, Abby. So it will now help it to increase the yield of this hydrolysis, because H plus is in the product, is in the reactant. So it will help us to increase the rate of hydrolysis, which is the forward reaction. Although it is still synonymous to this option A, but if you want to be very specific, so we just say it will help in increasing the rate of the forward reaction, hydrolysis rather. So a hydrocarbon has an empirical formula of CH. So I told you, if the empirical formula is what? CH. They now said it has a vapor density of 39. Now this is the logic. If your vapor density, I told you when I was teaching you empirical molecular formula that your empirical formula times N will be your what? Molecular formula, right? So or you can just say equals to your molecular mass. Now what is your molecular mass? Your relative molecular mass is equals to 2 times vapor density. Now they now say your vapor density is 39, so it will now be 2 times 39. That will be 78, Abby. So it means your CH now is into bracket N will now be equals to 78. Now what is the molar mass of carbon? 12. Hydrogen 1. So into N into 78. So we have 13N is equals to 78. Divide both sides by 13. Divide both sides by 13. So what do we have? So our N will be equals to what? So 78 divided by 13. I think we'll be getting around 6. So we're getting around 6. Yes. Yes, so we're getting around 6. So that's our n. So you now say CH now into bracket n. You now put 6 in front of that. In place of n, it will now be 6. It will now be 6 is H6. So which compound is this? This is benzene. 6 is H6. So that's option D. Now polystyrene is widely used. Some questions they will not even tell you it is 6 is H6. They will just say benzene. This is propane. This is propane. This is ethane. They will just say it like that. So if you don't know the name for benzene, that 6 is H6 represents benzene, then you're on your own. No? So this is benzene. This is propane. Where I taught you in that introduction to organic chemistry how to do it. So this is ethane. So polystyrene is widely used as a packaging material for fragile objects during transportation because of it. So what's the answer? Polystyrene. So why is it that we use polystyrene for packaging materials for fragile objects during transportation? So why is it that we use it? Oh yeah, I'm waiting for your answer. Oh yeah, oh. So look at the option. Is it lightness? Is it high compressibility? Or what do you think is the answer? So the answer is high compressibility. Because fragile objects can be able to you can be able to compress them. Although it is still light, it has low density, right? But if you want to be specific, the main reason why we use it is because it has a high compressibility. So the process of converting linear alkanes to branch chain and cyclic hydrocarbons by heating in the presence of a catalyst is called what? To improve the quality is called what? That's reforming. I told you cracking is breaking down of large molecule of hydrocarbon to form a what? A lighter one that are more marketable and usable. So that's why you have that. You notice that people use petrol more than they use diesel, right? More than they use bitumen. How many people are using bitumen? How many people are using all those larger fraction of petroleum? So the answer is reforming. So reforming is when you're now converting linear alkanes, you're now converting them to branching. Now there's something we need to know. There's something we call octane number. I did not teach you this. Octane number. So octane number is the what? Is the measure of or the percentage of 2,2,4 trimethyl. I've forgotten this thing. Is the percentage of 2,2,4 trimethyl. I've forgotten the compound. Just try to know it. That octane number is the percentage of 2,2,4 trimethyl. I think pentane in a particular petroleum fraction. So the higher the percentage of this fraction, the better the performance of that petrol. So this octane number is also the measure of performance of petrol. So if you have a petrol and that petrol is it has a good performance, it is because that petrol has a high octane number. So please, they may also ask questions on octane number too. So I did not teach you because of our time. So but I think you are just go and read about it. So petroleum fraction that is used in heating furnaces in industry. So what do we use for reheating furnaces in industry? So which one? Which petroleum fraction? So this is the last question for today. So yeah, the petroleum fractions. So that is the last question. So no, it's just 50 questions. So the answer is just diesel oil. So that's our answer. diesel oil is what we use in heating furnaces in industry. So thank you for watching today's video. I hope you understand something. So that's just some of the things, because you notice that most of you may not show up for live sessions. That's why I just try to say we should just go for these just recording it and just sending it to you, because I'm kind of busy now these days. And please try to revise some of the topics that you know that I talked about today, that you don't really know them. So I was right. So 2,2,4 trimethyl pentane. So that's also part of that octane number I was talking about. So I think with this we are done with that year chemistry UTME 2014. So if you are watching this video on my YouTube channel, make sure you subscribe and don't forget to comment. Let me know the school, the state you are watching this video from, and God bless you. Bye.